Okay, so we complete the chapter 2. Do you have any question about the chapter 2 or chapter 1? Is there any question? Actually, I upload some homework in the LMS system. Okay, so the due date is next week. Okay, so if you don't have, let me start. Let me start the next chapter. So we learn about the instruction set architecture, right? So we learn about some binary format and this assembly code. So now what we are looking at is we will implement the hardware to execute each binary code. Okay, so we learn about some logic design, logic first, gate and logic, and then combining these logics, we will make a processor. Okay, so we'll make a learning processor. So first, we'll learn about the combinational logic. Okay, so let's look at what is this. It's like this, like XOR, exclusive OR, exclusive NOR. So let's look at it. Okay, so exclusive OR. As you know that both input are equal, then the output is 0. Okay, so input is 1, 1, then is output is 0. 0, 1 case 1, 1, 0 case 1. That is called exclusive OR operation. Exclusive not OR, exclusive NOR case, it is just not of the output of XOR. So this is opposite. Okay, so we will implement using some basic gate for this kind of a little bit complicated logics. Okay, so first, what we are learning is, so we learn about the some gate. So we learn about the AND or NOT. So using these three operations, we can make any kind of complicated things. So using these things, we can make a NAND. NAND is not AND. NOR, which is not OR. Okay, so for instance, NAND case, NAND is, so there are two inputs, and X NAND, Y means 0, 0, 0, 1, 1, 0, 1, 1. So X and Y is 0. NAND is not of the result, so it's 1, and this is 1, 1, 0. So this NAND, NOR is just opposite one. So NOR case, X NOR, Y case, 0 or 0 is 0 and not. This is 1. 0 or 1 is 1 and not this 0. 0, 0. So this is NOR things. Okay. So let's look at then how can you make this, how can you really implement this AND or NOT gate in the real hardware. So in order to make this hardware, we have to know about the switch first. Switch is like this. As you can see that. So here there is a high voltage, and this is connected to the ground. Okay, so let's say this is 1 voltage and this is 0 voltage. Okay, so here this is switch. So if this is open, for instance, 0 is representing open, close means it is 1. Okay, so we are giving this kind of meaning. Okay, then we are measuring the voltage here. Okay, so we are measuring the voltage. Okay, so switch is 0. Then what's the output? Output voltage is what? Okay, switch is this is input. So input is 0. That means it's open. In that case, what's the output voltage? Let's say 1 voltage is 1 and 0 voltage is 0. Okay, so then what's the output value if the switch is open? So switch is open, then there is no current, right? So this is just, there is no current because nothing is connected. So that means this is also 1 volt. Because there is no current. This 1 voltage is just same to the end point. Okay. So if we are measuring the output point, then the voltage of that output point is just same to the 1 volt. Okay, so it will be 1. If input is 1, then what's the voltage in the output? If this is closed, then there is current. So current is flowing, right? So here there is a resistance, right? So the voltage of this part, so that part is same to the 0 voltage. Only 0 voltage is just connected, and between 0 and 1 voltage there is a resistance. The voltage is dropped, so it will be 0. So output is 0. Okay, so the switch is open, then there is no current, which means that the 1 voltage is just connected to the output. If it's closed, then the current is dropped because of that resistance. Or you just simply thinking that the output part is connected to the ground, right? So ground is connected to the ground directly. It's 0 voltage. So then what this meaning? This is actually representing not, right? So input is 0 case, output is 1, input is 1, then output is 0. This is not operation, right? Okay, so how can you implement AND operation then? AND case, we are making this kind of switch. So this part is connected to the ground. Let's say there is resistance, and this is connected to the high voltage, 1 volt, and this 0 volt. Okay, input is X, Y, and we are measuring the output here. So X, Y, output. 0, 0. So both are open, right? Both are open. Then what's the voltage in the up part? Yeah, 0 because it's just disconnected. So this 0 is same to the here. So 0. 0, 1. So X is open, Y is closed, but still the current is not flowing. So it's 0. 1, 0, 0. Right? What of the 1, 1? Yeah, 1, 1 case, the 1 voltage is actually connected to the up part. So it is 1. Okay. So using the switch, we can implement AND operation. 1 bit AND. So then can you make a OR using the switch? How can you make a OR? OR. So OR case, the AND case, the switch is sequentially connected. OR case, it is connected parallelly. Parallel connection. Okay. So this is up. X, Y. So X, Y, up. So 0, 0, both are open, then output is 0 voltage. 0, 1 is connected, so output is 1 voltage. 1, 0 is connected, 1. 1, 1, this 1. Okay. So if we have a switch, then we can make AND gate, so AND gate or gate or NOT gate, right? So if we have a switch. So the only thing you need to implement is switch. So how can you make a switch? So if we have a switch, then we can make a gate. So gate means AND or NOT, right? AND gate or NOT gate. So how can you make a fast switch? So that's the only things we have to do. So to make a switch, what we are using is we will use transistor. So using the transistor, we can make a switch. Okay, so let's look at a transistor. Transistor looks like this. It is based on the silicon. Okay, so silicon. And in this silicon, what we are doing is we are giving a lot of free electron. Not a lot, a little bit electrons here. Okay, so we are doping some electrons, like we are doping like a lithium or a natrium, and it is generating the many electrons. Okay. Okay, so in the silicon, there is metal here, metal. And there is another metal here. Okay, so it's connected. So currently what we are doing is we are making the switch using the transistor. And then here there is an insulator. Insulator. Okay, so no current is flowing. And on top of this insulator, there is another metal. Okay, so this is actually switch things. Okay, so now if this is 1 voltage, then what is happening? If it's 1 voltage, that means there are many plus here, right? But the flux is not flowing because it's insulated, it's disconnected. But anyway, there are many plus. The plus is charged in the metal. Okay, so if this metal is a plus is charged, then this minus is moving to the surface because it is because of this plus. So after we are giving the 1 voltage in that part, then minus is moving. So electrons are moving here. Okay. At this moment, if we are giving the, so for instance here, this is ground. And this is 1 volt. So then what is happening? Plus is moving from 1 volt to the 0 voltage, right? That means actually minus electron. Electron is moving from 0 voltage to the 1 voltage direction. So this is possible because if the minus is provided from the 0 voltage, then it is going to the metal, and there are many electrons here, right? So electrons here. So there are many electrons here. So the electron can be moved from this location to that location. So it can be flowing. Okay. Because of the 1 voltage, plus is charged. So if we are giving the 1 voltage in the, so this is called gate. If we are giving the some voltage, 1 voltage in the gate, then it looks like a closed switch. Okay. If the gate value is 0 voltage, then there is nothing is charged. Okay, so nothing is charged. Then what is happening? Then the electrons are just locate this location. Okay, so the electrons are just dispersed in the silicon. Then the free electrons are moving to this gate, this metal, and then there are many electrons here, but this cannot be flowing. Okay, because the distance from this metal source to the drain, so it's too far from the left, right to the left. Okay, so electrons are just accumulated in this location. Okay, and here this part will be plus are just located, but because of this distance, electron is not flowing. When the gate value is 1 voltage, then the free electrons are moving to the surface. Because of that, the switch is like a closed and the electrons can move. But if it's 0 voltage case, free electrons are just dispersed, then the current is not flowing. Free electron is not flowing. So it looks like a open. Okay. So it is just gate. It's like a switch, right? If this gate value is 0, that means it's open, it's disconnected. Gate value is 1, then it's like a closed, connected one. Okay. So using this transistor, we can make a switch, And if we have a switch, we can make a gate, right? So now you're understanding that how we can make an AND gate, OR gate, and NOT gate using the transistor. So now what is happening, what is left is using this AND or NOT gate, if you are making the processor, that means using the transistor, you can make a processor. Okay. So now we are starting from this gate. Okay, so using AND or NOT gate, we are trying to make a processor. Okay. So we will draw the gate. So this is line, and if we are circling, that is representing NOT operation. Okay, so the input is 0, then output is 1. So in this case, there's no direction. So for better representation, sometimes, actually it is always, we are giving this triangle. Okay, so anyway, the circle is, this is representing NOT operation. The triangle itself is just buffering. Buffer. So input is 1, then output is 1, input is 0, output is 0. It's the same thing. Okay, so circle means it's NOT operation. And this representation looks like the input looks like half circle. And there are 2 inputs and 1 output. This is representing OR gate. Okay, this is OR. And this is representing AND. Okay, so basically you have to remember circle means NOT, and half circle, I mean, the first one is OR, the second one is AND. You have to remember these things. Then how can you make a NOR? NOR means it's not OR, right? Not OR. So you have to draw the OR first. And then what is NOT? Circle is NOT, right? Small circle. So you are just drawing small circle here. So then this is NOR gate. Okay. So this is this small thing. This is representing NOT. So OR plus NOT, that is NOR. How can you make a drawing the NOT? Not the NOT, NAND, which is NOT. So you are drawing the AND first, and then add NOT. Okay, so this is representing NAND gate. And previous slide, we look at the exclusive OR. Because exclusive OR is also frequently used, so it has its own symbol. Okay, this is exclusive OR. Another line is there. And exclusive NOR. You can see that it's exclusive OR, and you're adding NOT, then exclusive NOR. Because exclusive NOR means not exclusive OR. Okay. So in the symbolized, let's say input is X or X, Y, and output is F. So F is X NOT, or we are saying that X NOT, or X NOT. So these 3 representations are actually representing NOT operation. Okay, so three things are equal. Or case f is x or y. And f is x and y. Nor f is x or y and then not. So this is also not or this representation or this representation. These three representations are actually representing nor. NAND x and y. That is representing NAND. Okay, so same representation. XOR case, you just remember that f equal x, y, and plus circle. That is representing XOR, exclusive OR. Okay. Okay. Then let's try to make a XOR using AND or NOT gate. Okay, so using this AND or NOT gate, let's try to make a XOR. So when what's the output of XOR? If two inputs are equal, then output is 0. Two inputs are different, then output is 1. So what we are simply doing is that, so there are two inputs. If two inputs are different, then it's 1, right? So it's different. So we are checking. So X is what? Y is different, right? Different means X equal 1, Y equal 0 in that case. So we are adding not here. Another case, X is 0, Y is 1. So XOR case, when this is 1, X, Y, X is 1, Y equals 0, then its output is 1. X is 0, output is 1, then output is 1. The other case is 0. So here, if we are looking at this gate, X is 1, Y equals 0 case. So this is 1. Then because of this NOT, it is 1, so output is 1. Lower case, it is 0, 0, output is 0. Okay, so we are combining these two inputs using OR gate. Then it's 1. Okay, so input is 1, output is 0. Input is 1, 0 case, output is 1. Input is 0, 1 case. Then the upper gate, upper AND gate, it is 0. And this 0 is 0. And lower 0 is going to not, so it is 1. 1 is going to 1, so output is 1. So output is 1. Okay. And 0, 0 case. 0. So input is 0. And the lower one is 1, output is 0. And this is 1, and this is 0, output is 0. So output is 0. 0, 0 case is output is 0. 1, 1 case. 1, 1. Input is 1. The second input is 1 because of this NOT is 0. So it's a 0. And X input is 1. And because of NOT, it is 0. and OR is 1, so it's 0. So after 0. Okay. So this is actually presenting the exclusive OR. So using 2 AND, 1 OR, and 2 NOT gate, we can make a exclusive OR. So there is a figure. So you can use this NOT, or you can just add another operation here. So anyway, this is implementation of exclusive OR. Okay, so then let's look at a little more. So let's look at the bus. Okay, bus means it's more than one signal lines. So one line is representing one bit. So it is carrying the one bit. So sometimes we need drawing many lines, like 32 lines. Then it's very hard to draw, right? So if we can like a 32, that means it is representing 32 lines. So this is called bus. Okay. So bus is a set of lines. Okay. And for this one, we'll look at it later. Okay, so we'll look at it. So we can connect some lines. Okay, so anyway, what we are doing is we will use some simulator for this logic design. Okay, so just by writing is not gonna be enough to understand this logic design. So we will install the Logisim in your computer, and then we'll learn about how to use these Logisim things. And then you will implement your processor using this Logisim simulator. Okay. So first, what you have to do is you have to install it. Okay. So you have to Googling the Logisim and then download it and then install your system. Now, so can you try to do? And if you are finishing, please let me know in the chat window. So I will also do it. So do the Googling. Okay, so if you download it, you can see that there is a program, Logisim. It should be working. Actually, I'm using some the recent system. Because of that, it's not going to be working. I'm using the M1 MacBook. So it's not working. So let me try. This is not going to be working. Okay, so my one is also M1. It has some problem. Let me try to do. Just wait a minute. Mm, Figure it out. Okay. Is there anyone who is succeed to learning the Logisim? Okay. So if you are succeeding, then please implementing the. Okay, so just look at the slide. Okay. And if can you let me know, is there anyone who has a problem to learn the Logisim? Okay, Mac has the problem. Okay. One you have to do is So if you're in the Mac, first you have to download Java if you don't have a Java machine. Okay, and then I will upload Logisim the jar file. So let me I will load it into the LMS system. The LMS system lecture resource. Wow. Okay, so if we are going to the LMS system, I will upload logisim.zip file. If you unzip it, then you can see the logisim.jar file. Okay, so then let me see. Is it possible to? What you are doing is the reason why it's not working in the Mac is, so let me share. Let me share. Let me share the screen. Okay, so you can see this, you can download this Logisim, right? So everyone can download it, right? But maybe you cannot run it in the Mac system. So in the case, what you're doing is looking at the package, then there is a content directory, and I think there is, yeah. If you're going to the content resource, then there's logisim.jar file, okay? So you just need to execute this file only, that's enough. So you are copy this file in any place, okay? So you're moving this one outside, or you're moving this one into some location by copying it. Can you do it? So you can copy it, I think. Okay, so you can copy it and then you can learn it even in the Mac. Okay, so can you try? So if you have a Mac case, if you have a Mac operating system, then you have to move the logisim.jar file from the logisim things. Okay, so can you let me know whether you can succeed to the learning logisim? So I'm learning on the M1 system. Okay. Chaeyun, do you succeed or not? Okay. 이석철, can you learn it or not? Hmm. Can you download the Logisim file? And then can you do the package content? Can you learn it? Mhm. So then everybody can do that, right? Right. Okay. And let's look at this. Okay, so if you are looking at this Logisim, so here the top left part, there's toolbar. Okay, so there's toolbar. Normally you will use this finger and also this point you will frequently use. And this A is representing, you can make some label, you can write some comment on this design. And here, this one, the rectangle, that is representing input. This input, and circle is representing output. Okay, and this is not and or. Okay, so because these are used frequently, so that there is this one. And anyway, this window is representing the library. So you can press, so here you can click it, okay, and then click and drag and drop into the, not the drag and drop, just click and just move your cursor, okay, without any clicking. And then press it. Okay. Then about this information is representing in this location. You can change the facing. So now it is pointing the east part. You can change to west or south or north. So any point you can change it. Okay. Also, you can change the data bits. So here everything is 1 bit, but you can add like a 32-bit or 8-bit. You can change also bit side and gate size. You also change it. Small, wide, medium. Okay. And input, number of input. Currently there is a 5 inputs. You can change into the 2. Okay. So 2 inputs. Okay, so then let's draw this gate and then input. Input, input, output. So can you draw it? So you can then please let me know, and we will go to the next step. And then let's try to connect it. So if we are moving close to this rectangle, so you can see that the green circle is there, right? So let me. So if you have that, the green circle. So then you are pressing the mouse and then move like a drag and drop. Move until to this location. So then it's changed to darker green. That means it is connected. If it's not connected, then it looks like a blue or it will be red. So you are connecting everything. So if you can do it, please let me know. Mhm. Okay, then let's try to change the input value, okay? So how we are changing the input value? Press the finger. Top left, there is a toolbar, right? Finger, and then move the finger. So you are clicking the input, then it's changing. Okay, changing. So it's toggling. Okay. So then let's try to org it also. So can you make a org it also? So change the input value. Number is 2, and there are 2 inputs, 1 output. Okay, and also to the NOT gate. And then change the input value. Please let me know you are completing to draw this 3 gate. And if you have a problem, please let me know also. Okay. So everybody can do that. So if you are completing, then can you draw the XOR using the AND or NOT gate? So how can you make a XOR? I'm just doing the copy and paste. 2 inputs, X, Y, and output value, value. Then, no, not this one. Can you draw this XOR? So if you're completing, press this arrow button, and you can give a name for this input value. So let's say this is X. This is Y. Okay. And output is, let's say this is F. So you can give the labels. Okay. So you can compare using the XOR gate. Let's try to. So you can see that the same output is generated. So everybody finish or are still drawing? Maybe you have some trouble. Some people has trouble. So please let me know. Please ask me. Okay. So when you're looking at the schematic, the light green means it's 1 and dark green means it's 0 value. Okay. And also some input is not there, then the output will be, so error signal is propagated. Okay, so if you can see the red line, that means some input is not correctly connected. So if you are just connecting like this way, it's working. So for instance, like if you are drawing the like this, so it looks like it's connected, but actually it's not. Okay, because this is port. So you have to be careful about that. Or in some case, if you're connecting these two input, and so in some case, this is conflicted. So one is generated, another one is not zero, then it has problem, right? So in that case, it is generating the error. So any question? Okay, so then we will continue to implement some little bit complicated logics using this simple and or not gate. Okay, using this Logisim simulator in next time. Okay, so no question? Okay, so see you on Wednesday. Bye.